So this lesson we're going to be talking about radicals and what are called rational exponents, which are basically fractions as exponents. So the first thing we're going to talk about is we want to talk about roots and how it relates to radicals. So we've talked about what kind of familiar root before. We'll hopefully remember square root. But we don't have to always deal with the square root, right? A square root is just when you multiply, or what number you multiply by itself twice. We can have an nth root, which is just basically how many times you've multiplied a number by itself to get your final product. So for example, if b to the n power equals a, then b is the nth root of a. Giving you a numerical example could be like if 2 to the third is 8, then the third root of 8 is 2. So we're just basically going back and seeing what number did we multiply that number of times, and that's the nth root. Okay? So the way you'd write a radical is with that square root symbol, right? And you'd have the radicand on the inside. So for example, a, that's what we call the radicand. The symbol itself is what we call the radical. And then this little n right here, this is the index. And that's basically saying how many times did we multiply a number by itself, right? So for example, the third root of 8 is 2, because 2 times 2 times 2 gave us 8. Okay? All right. Let's take a look at the core concept here. Real roots of any number, a. So as long as n is greater than 1 and a is a real number, then we have certain things happening, okay? If our number is odd, then we only have one real nth root, okay? And notice how when we write our nth root, if you wanted to rewrite it as an exponent, it's going to be 1 over n, right? So kind of nice to know there. If we have an even number, then we have a different situation. So if we have an even number that's greater than 0, that's positive, then we have 2 real nth roots. Okay? Now if we have an even number, but now it's equal to 0, then we have 1 real root, which is just 0. And finally, if we have a number that is even and a is less than 0, then we have no real roots. So let me give you some actual examples of numbers so you can see what I'm saying here. So when n, our index, is is odd, for example, like we said earlier, that 3, then, and the number inside will have 1 real root. So if we're looking for the third root of -8, the answer here would be -2, because -2 times itself 3 times is -8, right? If we're looking at the second one, if our number is even, our index is even, and we have a number greater than 0, then we have 2 real roots, the positive and the negative side. So for example, if we're looking at the, let's say, fourth root of 16, then it's going to be plus or minus 2, because it's got -2 times itself 4 times to make positive 16, or +2 times itself 4 times to get positive 16. Okay? And then we'll talk about why we might want to write our answers as 1 over n and stuff like that in a little bit. But if you wanted to see how to redo, let me back up and show you how to rewrite it as a fractional exponent, and then show you the answer again. So if you wanted to make sure you can see that, it's -8 to the 1/3, which was again -2. Why is it 1? It's because this entire radical is raised to the first power. That's why. Okay? Same thing here. If you really wanted to write it as a fraction exponent, as a rational exponent, this would be 16 to the 1/4, which ends up being plus or minus 2. All right. Again, if our index is even and it's 0, then the answer is 0. So that pretty much sums it up, right? If we're looking at an index that's like the square root of 0, there's just 0. There's no way around it. And then finally, if we have like the square root of a negative number, this doesn't exist for us. There's no real roots. Okay? So let's look at the first example, and we're just going to find the indicated nth roots. So what you'd want to do here is rewrite it as the radical. So remember, the radical is going to be the n as our index and a on the inside as the radicand. So I'm going to rewrite this using my format. So negative 64 goes inside, and my index is 3. Now, if you don't know off the top of your head what times itself 3 times is 64, what you can do is always do a factor tree. Okay? So what I'm going to notice here is right away it's n is odd. I should have one real root, and that's going to keep the sign of the original. So I know no matter what, my answer is going to be negative. And then what I'm going to do is I'm going to go ahead and do a factor tree out here with 64. So I know this is 8 and 8, which is 4 and 2, which is 4 and 2, and again 2, 2, 2, 2. And I'm going to look at my prime factorization and simplify. Oops. Let me erase this for a moment. And let me simplify that radical. So I know it's going to be a negative. I'm still looking at the third root of 64. And I know that 64 is 1, 2, 3, 4, 5, 6 2's multiplied together. And what's neat about this is this 3 on the outside tells me the grouping I'm looking for. And I drop my negative. Let me put my negative back there. Okay. So the 3 on the outside tells me what kind of groups I'm looking for. I'm looking for groups of 3. So I want 3 of a kind here. So now I can simplify this to the negative third root of, I'm sorry. Let me actually make this even simpler. Once we have these groups of 3, the 3 basically takes out each group. So what's left over is 1, 2 from each group. So I have a 2 there and a 2 there. So this is going to become negative 4, and that's my answer. All right. Same thing here for B. So I'm going to set up my problem. I'm looking at the index is 2 and 81. It is even, and a is greater than 0. So I know there's a plus or minus. There's 2 answers. And here, hopefully remember, an index of 2 is basically the square root. So the square root of 81 is just plus or minus 9. Okay? So go ahead and try 1 and 2 using that nth root notation. And remember, go back and double check what kind of numbers what kind of answers do we have? 2, 1, is it positive, negative, and whatnot. Okay? Let's go ahead and try 1 and 2. So check your work. Make sure for number 1 it's a negative 5, and number 2 it's plus and minus 2 because we have 2 possible solutions. Okay? We're going to stop right here, and then we'll continue this in class looking at simplifying our rational expressions, our radical expressions, and working with our rational exponents. Thanks for listening.